Yesterday I managed to make this module. I probably stayed 1 hour and look very carefully what pins of this microprocessor I will link to all the necessary pins or pads from all my project. So I have these 3 pads that corresponds to my LCD driver. These 3, they must be linked here, and I have them here specified. And I choose specifically and very carefully I choose these 3 pins, which is 1, 2 and 32 here. I also put some very thin wires to designate exactly where I'm linking them. Here, clockwise, counterclockwise, and button 0 is from the rotary encoder, which is this one. So I have other 3 pins linked to these pins here. I actually made a short list where I split everything. I specified which is the IC, this is the IC pins, and which is the Arduino Uno R3 board pins. So I didn't specify it here because I didn't need it to, but in that list I had to, because on Arduino R3 board they are giving me extra information what these pins means. 9, 10 and 13. I couldn't put them one next to each other, only 9 and 10, but not 11. I had to jump to 13 for the RGB pins, for this little thing. Actually for this pad, which will be on this other side. It needs to be PWM to vary the voltage pretty much. 0 to 255 per each pin. Getting back to here, here I had a choice to use interrupt pins. Those 2 interrupt pins are 2 and 3, I believe it was. And I only have only 2 interrupt pins, but I have 3 buttons. So the code that I find originally was to use the interrupt pins to manage the button click. So clockwise and counterclockwise are actually 2 buttons. They are behaving like 2 buttons. But this is actually the clicky button which you are pressing it. So this is a obvious button, but the rotary buttons are not that obvious they are buttons, but their behavior is exactly like a button. So theoretically I could use those interrupt pins for the rotary and leave the button for something else, for some other pin that is not using interruption. But in my mind I said, well, one problem is this chip layout, and the problem to link the wire to this encoder, and second, maybe I should make or find another type of code that will be most probably more complicated to make, different from that interrupt pin that was very easy to implement. Actually, I really like it, and I also test that code as well, and it did give me some good, very interesting results. But I had some skipping. I catch some skipping of the rotary encoder. If I was moving too fast, if I was turning too fast like that, it was skipping some steps, so that was a problem. So my idea is to create a new function that will deal with all these 3 buttons. So a single void function, something like that, that will do all this job, the same job per each button. This is what I have in my mind to do. One single function that will deal with all 3, or whatever, how many buttons I will add later, making exception of this one. So I will have this one, and maybe other buttons I will link in the future to this port, whatever, really whatever. And I will use that function for more than 3, what I'm having here. So that is my plan. The idea is not to be limited to only those 2 interrupt pins and be the slave of them. I was thinking actually to make some sort of demultiplexing for how many buttons I'm having, and using only these 2 interrupt pins per each demultiplexed button that I will use in the future. But in this case only for 3, but using only 2 lines. I don't know how to do it yet, but I know it is possible. I have to make some extra research, and that will take time. But it is an idea, and I put it on the table as an idea. Everything is possible if you put your mind to it. So that's all about this part. Pretty much I have a very limited space here, so maybe it will be here, maybe here in the middle, maybe a little bit on the margin. I have no idea where exactly on this line, or how high or how low, but it will be in this sector. And unfortunately it will be a little bit up, not in the middle here, as I originally wanted to be. I wanted to be here in the middle. Or probably I can do exactly what I did with the LCDs, and I can bend the pins a little bit and actually mount it here in the middle on a cardboard, and then drag the wire underneath wherever they need to go. If I want to make some holes and poke this element through those holes, like I originally did on the 3D sketch, I did this, exactly this, and it didn't work good for this tree. I was extremely limited. But here, with this approach, I believe it's possible to mount it actually in the middle here, and then drag the wires. Yeah, this is a lesson for me as well. I mean, I know all these things, I do them a little bit mechanically, but sometimes I'm seeing something different, and I'm thinking maybe that will work better than my experience that I'm having. And it turns out my experience is the best. The idea is that I'm trying X and Y things, because it's good to have a solid way of doing things like I'm doing it. It's very good to trust your experience. The way you are doing things is very good. This was my entire mentality, to build a very strong experience and to know exactly mechanically, automatically, to build whatever I'm building from instinct, automatically to do it. That was my original plan from when I was a child. That's how I learned everything very well, actually, through experience. That was the mentality that I followed all my life. Pretty much. I finished with the subject, you get the idea. So now back here, this chip, this RGB chip, exactly this one, that I didn't lose it all this time from the very beginning when I started with the first board. I believe it was this LCD. When I cut this this cardboard. Actually, it wasn't this. It was this one that it failed. Like I said, when I used that principle of putting the LCDs in this knob through the cardboard and not on the cardboard like it is here. Here is on the cardboard soldered, and then drag the wires underneath it wherever it needs to go. So this little RGB LED, I didn't lose it from when I started everything. And I'm very proud that I didn't lose it. Actually, I was keeping one eye on it all this time, not to lose it, not to fuck it up. It is a hero of all this experimentation as well. So this little RGB chip is having these 3 negative lines, 1 positive pin. So it is commanded through those 3 negative pins and 1 common positive. 1 common positive, it will go here at this 5 volts. Of course, with a resistor on it. I will have to add a resistor. I looked very carefully, like I said already, I stayed probably 1 hour to check and double check and triple check if everything is linked correctly and how well is linked. And also the direction where the wires are coming, how can I link them. Partially, I was lucky to have these pins down here. If they were here on the top or on this side here, well, it was nasty, more nastier to deal with. But I was partially lucky to have them here on the bottom, and also to be, like I already mentioned, to be PWM, because it needs to be PWM, specific PWM pins from this Amiga. It has 6 PWM pins. So I don't think this is a normal RGB LED. I believe the normality that you can find them is positive, 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 and a common negative. Most probably. I didn't check this little detail. I only bought this RGB model LEDs and I settled with it. I said I will deal with it myself, and I didn't actually compare it with other on the market. They were extremely cheap from eBay or AliExpress. I don't remember from where I got them, but they were very cheap, 100 pieces. I extremely rarely use them. I'm only using them in very special projects. And yeah, this is it. Probably if you are having other model of RGB LED with positive, 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 so inverse what I'm having here, you will have to adapt the code to it. But the pins can be exactly the same as I'm having them here, with this little note that they must be PWM pins. I'm not an expert either. This is the first project when I'm using these chips, literally the first projects. I am quite accustomed with these chips until now because I did the tests on breadboard. But this is actually the first final product or final prototype, if you want, when I'm using these 2 chips. Now the wiring, the actual wiring, I have to drag these wires from here to here, take out these ones that I used them on the breadboard to test the chip, and it worked flawlessly, and I'm very, very happy because it worked. But now I have to drag them here, and from here, as you can see, these pads, these 4 pads, and another 2 wires from positive and negative rails as well. So 6 wires in total I will have to drag to actually program this chip through Arduino. They are called in-serial circuit programmer, ICSP. And this will be a bit more harder than linking directly from here. Well, a bit more complex, not hard, a bit more complex, because I will have to add a special program into Arduino board, and from there I will have to pay attention to very specific details to keep an eye on them to be everything correct. But after that, this will remain here as a standalone chip, and that's it. For this project, this is it. This is what you see, this is what you get. All right. So next I will have to link, like I said, these pins here, and actually make the board for this element and make it very secure, because this is a heightened element. It can be knocked off. I can rip off the solder or the pads or the entire cardboard. It's very tall, and you have a lot of leverage from here, from when you are manipulating it, and is posing a lot of force here on the base. As I'm planning to make it, if I'm not inserting it through the cardboard. Also, this is the first time when I'm using a rotary encoder. I never used a rotary encoder until this project, so this is a novelty for me as well. And I really, sincerely, I have no idea how to program this rotary encoder. I'm relying on other codes on the internet, but pretty much that's it. I don't know what and how I will code this. When I will program this chip, it will be the first time for this encoder to program it as well. So I will test the code for this rotary encoder many times until I will get it right. Most probably, or I will actually put it on a breadboard and program it, find the program specifically for it, and then adapt it here. We will see what I will do. So now, how to put this little fucker here? I'm still thinking to pass it through the cardboard. It is occupying some space, not a terrible space, but yeah, like that, a little hole there, and that's it, you know, and I'm having it. But I also have to take in consideration this diameter of this disc here, not to get outside of, and if it's getting outside, what? It's not the end of the world. No, it is too on the margin here, somehow aligned. But it will be nice to have the original design here in the middle. It will be awesome. All right, enough talking, more working. Now I will put it here, I decided. negative, 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 and positive, and that is opposed. That positive pin is opposed from the marking. It's having a tiny triangle there, and that is the marking. Unbelievable. Yeah, they are definitely reboot components. They didn't they messed it up, and they sold it as very cheap. So I can see the marking here on this corner here, there. So the positive is there. Unbelievable. Yeah, it's good to have this helpful sketch. So I want the positive wire to go probably here. But I don't have space to put a hole in it. Maybe through there and coming out through somewhere here. Yeah, you see how I'm soldering exactly on the pin. Now to actually test it, I will need 10 kilo, and to test the pin out, and if I burn it while I was soldering it. Let's make it again. So there is positive, here is negative, negative, and negative. Excellent. Yeah, it's very good that I had this, because I was assuming that this little marker is a little triangle there. It's having a tiny little bit of white triangle there on the chip itself as well, is exactly as in my drawing here. And I was assuming that triangle is the positive, but it's not. is in the opposite side. So this is definitely fucked up from factory, RGB, and they sold it like that. That's why it was very cheap, but it's good enough. which I'm thinking to take out from this board that I was testing before, in-circuit serial programmer. Before I will link all this, I should add these two wires, positive or negative, to here. It's from 0 volts to there and positive 4.5 volts from there. It's very nice. Okay, it's looking like a bomb. Cut the red wire. And now this things, which I'm not very happy with this positive and negative, how large the pads I put there. I should have put larger pads like here. This is why it's good to have color codes. I'm not even looking here and I know it's positive and negative, but I will still double check them. Yeah, are this in the margin, plus and minus on the corner here. Good. And this one in the middle is mossy, which is here. Very, very easy to access this side. What I don't like is this thing that I have to attach it every time I'm trying to reprogram that microprocessor. So this one, which is MISO, and here MISO, and this way is serial clock, which is here, and reset. I should actually mention here. So reset is on pin 10, if I remember correct. That's where this wire will go, and it's from here. So all this beautiful wiring that you are seeing here are for Arduino Uno in serial programming option. Alright, I hope I connected everything correctly and I didn't fuck it up. And after I'm programming this chip, I can take out all these wires and it will remain a standalone and hopefully working circuit. Fantastic, fantastic job. Okay, pretty much this is it. I believe I'm done. It's good enough. Thank you very much for watching, and next it will be the programming. I hope I will not have to come back and repair anything. I hope I wired everything correctly. Quite complicated project, but it'll be fun. It'll be, in the end, it will be awesome. I really like these wires here, how they are. Excellent, excellent. All right. See you next time. Bye bye.